Hey, geometry. So today we're going to get into some actual properties relating parallel lines and some of the transversals and things we were looking at yesterday. All right, so we're going to start out with a postulate, one of those things that we don't feel necessary to prove, just kind of is evident in of itself. And so this is the corresponding angles postulate. So if two parallel lines, parallel lines in the same plane, so they run side by side, they never cross, right? They're running at the same angle, you can think of it, and they never cross each other. So over here in our picture, we've got parallel lines here and there. And we mark it with that little triangle, or I'll just do like a little arrow sometimes to mark those parallel lines. You can see a couple more parallel lines down there. So those are parallel lines. If we have parallel lines cut by a transversal, then each pair of corresponding angles is congruent. All right, so corresponding angles like 1 and 3, all right, and you can kind of see this, it's just kind of evident, right, this postulate, with that parallel line cut by this transversal, angle 1 is congruent to angle 3. Those are the same angle. So, for example, angle 1 is congruent to angle 3. And we could go around and do all these. Angle 2 is congruent to angle 4. And then angle 5 is congruent to angle 7. Angle 5 is congruent to angle 7. And 6 would be congruent to angle 8. So all of the pairs of corresponding angles are congruent within that. All right, so we're going to go ahead and use that corresponding angles postulate. If in this figure the measure of angle 5 is 72 degrees, so let me put that in there, 72 degrees. Find the measure of each angle, tell which postulate or theorems you used. All right, so we want to know the measure of angle 4. Well, if we know angle 5 is 72 degrees, angle 4 is corresponding, right? It's kind of on this bottom left of this intersection, bottom left of that intersection. These are parallel lines, so angle 5 is congruent to angle 4. And so we know that angle 4, the measure of angle 4, would be 72 degrees as well. All right, and so what postulate did we use in that? That is our corresponding angles postulate, right? So that's the one we just learned. Corresponding, I'm going to shorthand this, angles postulate. You could probably write that out, but just going to kind of go shorthand with that one. All right, so this we know is 72 degrees. What about angle 2 up here? What do we know about angle 2? Well, we could go back to what we already know. Angle 4 and angle 2, those are two lines crossing. These are vertical angles, and we know vertical angles are congruent, so we'll know that's going to be 70 degrees as well. Sorry, I don't need the percent sign there. 70 degrees as well. So angle 2, the measure of angle 2, is also an equal sign up there, is also 72 degrees. And we know that there's a couple ways we could get this. We could say vertical angles, and that's what we know so far. But there's actually another way we'll come to in a second, so I'm going to put it in here for now. We could have also said alternate exterior. Angles. This is a theorem. And we really haven't learned this one, but I'm going to put it here, a little note, see below. So right down here, we've got this alternate exterior angles theorem that basically says, if we know angle 5, the alternate exterior angle is congruent. And you could we could go through a very short proof of that by proving that, well, if this angle, whatever this angle measure is going to be the same as that angle measure, and then that angle measure, we know is congruent to that one because of vertical angles, and so combine those together, we know that alternate exterior angles will be equal, and so actually our the measures will be equal. 6 and 1, those angles are congruent, and their measures would be equal. But vertical angles works for now. The vertical angles, and that is a theorem as well. We can prove that from our linear pair postulates. So, all right. Next, we're going to move on to some other theorems. We've got the corresponding angles, what about all our other angle pairs? They all have a relationship. So alternate interior angles theorem, if two parallel lines are cut by a transversal, like we have pictured down here to the right, if two parallel lines are cut by a transversal, then each pair of alternate interior angles is congruent. So going based off this image, our alternate interior angles, and you can kind of see it based on the look of these. So angle 1 is going to actually have the same measure as angle 3. So angle 1 is congruent to angle 3. And angle 2 is congruent to angle 4. And so that is the alternate interior. We know that the alternate interior angles are going to be congruent from that. And you could go through proving that, which I'm not going to do here, but we could later, using our corresponding angles. Like I know 2 is congruent with whatever angle we would write right here, maybe 5. If this angle is congruent with this one and then 4 is vertical from it, well, then those are going to be congruent to each other. And that'll always be the case if we have the parallel lines cut by the transversal. All right, again, if we have two parallel lines cut by a transversal, then each pair of consecutive interior angles, so staying on the interior, they are going to be supplementary. So these are supplementary. They add up to 180 degrees. Angle 2 and 1 are same side interior, so the measure of angle 1 plus the measure of angle 2, those add up to be 180 degrees. And then we could also say it with 3 and 4. The measure of angle 3 plus the measure of angle 4, that will add up to be 180 degrees. So this pair is supplementary. If these are congruent, then if these two are supplementary, so 1 and 4 are supplementary, and if 4 is congruent to 2, then 1 and 2 are supplementary, and as well as 3 and 4 add up to be 180 degrees. All right, and then the last one we're going to add in today, the alternate exterior angles theorem. So if we look down at the bottom right, we got some exterior angles there. If we're dealing with alternate exterior angles, so two parallel lines cut by a transversal, then each pair of alternate exterior angles is congruent. So 5 and 7 are congruent, and 6 and 8. Angles 5 is congruent to angle 7, and angle 6 is congruent to angle 8. And so that's what we could say with the alternate exterior angles theorem. And again, we could go through proving this if we wanted to. If I want to show that 5 is congruent to 7, well, I know 5 is congruent to this angle here because of vertical angles, and then those would be corresponding. Or 5 is congruent to this one because they're corresponding, but then it's vertical with 7. And so we can go through the process of proving that based on a couple things we already knew. All right, so moving on to the back. Looking at some quick applications of these. We've got Reading Lane and Creek Road are parallel streets. A lot of times we end up with parallel lines when people are making things. That intersect Park Road along the west side of Wendell Park. So there's Wendell Park. So basically we got our two parallel lines. We could draw a little I draw these little arrows to show that those are parallel. We have our two parallel lines cut by a transversal. If we know the measure of angle 1 is 118, and we'll assume that's in degrees, what about angle 2? Well, that would be, and if this is my transversal, that would be on the alternate side, and if they're both on the interior. So alternate interior angles are congruent, so we know angle 2 would also be 118 degrees. So the measure of angle 2 is 118 degrees, and we got that from alternate, abbreviate this, interior angles. Go real shorthand with that one. All right, some more applications. Using the figure at the right, use the figure at the right to find the indicated variable, explain your reasoning. So we've got our parallel lines cut by the transversal. We know the measure of angle 4 is 2x minus 17. So 4 is 2x minus 17 is that measure. And then the measure of angle 1 is 85. Find x. All right, so you can pause and try and figure this out on your own. There's a couple ways we could set this up and solve. We could realize that angle 3 is 85, and so we could set up some sort of, we'd have consecutive interior angles or same side interior angles and add those up to 180. So we could set up something along this lines, 2x minus 17 plus 85 equals 180 degrees. Which we can get the degrees out of there and just solve it as is, because I haven't been labeling the rest of these with degrees. We could have also done this way. We could have said, oh, 1 and 2 are a linear pair, and so I could have done 180 minus 85 to figure out what angle 2 is, so that would be 95 degrees. And so I could actually just set, these are now corresponding, 2x minus 17 equal to 95. Well, that's the same thing you would get if I actually subtract 85 right now. I would get 2x minus 17 equals 95. So you could have gotten there anyways. I'm going to go ahead and finish up adding 17 to both sides. So 2x is equal to, if we add 17, what are we at? 112. And if we divide by 2, x is going to be 56. So x is 56, and that's what they're asking us to find. If they wanted us to find that angle, we could as well. We know that angle is 95 degrees. If we plug in that 56, we could double check it even to make sure. 56 plugged in, 212 minus 17, yep, that's 95. All right, so this next one sets up a little different. Actually, I'm going to change colors here because it's actually reassigning some values here. So they're telling us the measure of angle 3 is 4y plus 30. So instead of this, I'm going to 4y plus 30. That's what the first bit tells me. And then the next bit is going to tell me that measure of angle 7 is 7y plus 6. So this is 7y plus 6. So what we've got here, we've got alternate sides. They're both interior, alternate interior angles. We can set equal to each other, those measures. So 4y plus 30 is equal to 7y plus 6. And at this point, we can find y solving this. So subtract 4y minus 4y. If I'm canceling 4y's over here, I'm going to bring our units over here. So minus 6 minus 6. I get 24 is equal to 3y. Divided by 3, we get y is 8. And that would be our solution to that one. All right, and I guess one last theorem for you. If a plane, in a plane, if a line is perpendicular, make sure I got this right, perpendicular to one of two parallel lines, then it is perpendicular to the other. So this is if we are dealing with a transversal problem and we have parallel lines. If it's perpendicular to one, which 90-degree angle is perpendicular, then it's perpendicular to the other. It's also going to be a 90-degree angle, and that basically follows from our corresponding angles rule. If these were corresponding angles, they'd have the same measure, be congruent. Well, if one's 90 degrees, the other's got to be 90 degrees. So if you got parallel lines, if you're perpendicular to one, you're going to be perpendicular to the other. And that's the last feature from this section.